Hey, Manish here. Last episode we built an agent from scratch, a real loop with two toy tools. It was all local, totally predictable. Today we are taking the training wheels off. We are giving the agent real tools, search the web, read and write files, call actual APIs, and that changes everything. Not the loop is still the same, but what the agent can do and what can go wrong when it does it. So we are talking about the stuff nobody likes, error handling, cost, and why you can't just let an agent loose on your API keys without guardrails. By the end, you'll understand not just how to build with real tools, but how to build safely. Let's go. So last time we had a calculator and a date function, useful for a demo. But here's the thing about agents in real world. The moment you give them real tools, a search engine, a file system, an API, the game changes. A toy tool is deterministic, same input, same output every time. A real tool is messier. Sometimes the API is slow, sometimes it's down, sometimes you ask for a document and it returns HTML. You have to parse. Sometimes the request costs money. And here's why it gets interesting. The agent has to deal with all that, not you. The agent reads the error, adjusts and tries again, which is powerful and which is also why you need guardrails. Let's talk about what makes a tool for an LLM. It's not the implementation, it's the schema, the description you give the model. Here's why. The model never runs code. It reads your schema and decides whether to call this tool. So if your schema is vague, the model uses the tool wrong. If it's precise, the model uses it right. A good tool schema has four things. One, a name, short, no spaces, obvious, not my own custom search function, version 2, just a basic search. Two, a description, one sentence, what does it do, when would I use it, the model reads this first. Third is the input schema, what argument does it take, what are they, what are the constraints, whether it's optional or required. Fourth, the examples in description. Examples, search the latest AI breakthroughs, returns, title, URL snippet, and the specificity that you give wins it to help it more defined. Last episode, we built tiny agent, a bare bones React loop that could reason but had no real power. Its only tool was a calculator. Today we fixed that. We are giving the agent 5 real tools: web search, file read, file write, GitHub API, and the calculator from last time. Same loop, same structure, but now it can actually do things in the world. In the agent with tools.py file, as you can see, the structure hasn't changed from episode 2. Tools are defined as Python functions. Each tool gets a JSON schema the model reads. The agent loop, that is think, call, observe, repeat. So let's walk through each tool. The first tool that you generally see is on the web search. So in this case, we could see that we have defined the web search tool, which the agent calls search API and get back live results from the web. Not training data, not a guess, actual results from right now. And the function, the web search that you see, takes query and a max result count, returns a list of dictionaries with title, URL, and snippet. And the API key is pulled from the environment, as you can see from SERP API key here, basically. And it is never hard coded. And if the key is missing, the function returns a structured error dictionary. It doesn't crash. The agent reads the error and decides what to do next. And I'm using SERP API here. And this you can use by registering to SERP API. And you can get the API key and use that in your .env. And you can swap it with DuckDuckGo, Google Search API, Bing Search. The interface stays the same. Send a query and get the result back. And for parsing of the respective result, in what we are going to receive is title, URL, and snippet. That's what the model needs to answer a question and strip out all the noise that are going to be required. And in this case, you can also see the exception handling that we have done. So 3 things to notice about error handling. Timeout is caught separately. The model reads search timeout after 10 seconds and knows to retry or give up. Network errors are caught and returned as dictionaries. The function never raises an exception. It always returns something the agent can read. The next thing that we are going to discuss is on the tool schema. So we will go ahead into the tool schema part. So in the tool schema, what matters is this is the what model actually reads. The descriptions tells it when to use these tools. Use this to find current information. That's the cue. The model catches your task against this description and picks the right tool. The input schema that you can see here basically is a JSON schema. Query is required. Max result is optional with a range constraint. The model will never call this with more than 5 results because the schema says maximum 5. This is how you constrain agent behavior without writing guardrail logic. Put the constraint in the schema and the model respects it. Now we will see through to run a search query for the task 1. So let me just go to the execution of this run agent that we have, and I'll just come use the task 1 for now to show the search. So here, as you can see, I'll just move my output cursor above. So you can see that the respective task has started. It is able to fetch information and said that no result found as part of the agentic news. It is trying a query something different this time for web search and now able to get the result. It's again trying to fetch. So it's right now in the step 2. The step 1, it was not able to gather the respective information and is trying with a different query. In the first time the query was latest news Agentic AI. Now it is finding the state of Agentic AI 2024. Now it has able to get the respective details and it has written the respective details as you can see, and it has been written to AI news file that we generally have over here, and it is stored in the workspace and stored as part of the respective outcome. And what exactly the final answer, the summary of it is, we have got different sources and also key insights from OpenOcean, IBM, McKinsey, Capgemini and all, and what are the respective themes and outcomes as part of the search. That's with the first phase. So if you see the first step as in the given context that you generally see is the model thinks and then web searches are done. So the agent orders those two steps itself. It didn't tell first search and then write. The schemas told it web search returns results, write file takes content, it plans accordingly. And now going to the, you must have seen the read file and write file operations here that we generally have. So in the case of a read file and write file, these are nothing but the operationals of file. So these are the two tools, not one, and not a single do file stuff function. They are separate tools, separate schema. The model know exactly when to read versus when to write. And this is a critical safety check that we generally use to path traverse check file in the read file to ensure if the agent or a prompt injection tries to read password or the absolute path. Basically here it resolves the full path and it starts with catches with the file system is touched. That's the guardrails that you're seeing right now over here. Okay, and next the constraint that you see of the workspace and all these information, these guardrails that you see over here. So max steps stops the infinite loop. The max file size stops a runway write from filling your disk. The search max result stops the agent from flooding its context window with 50 results. So define your limits upfront. And then you also have written a write size file check to sort of whenever we are going to write a respective file to ensure that here we have a safety file size limit. Okay, so if the agent generates too much of content and tries to save it all at once, this results an error and the agent reads it and it does not crash. The next thing that I want us to do is on the multi-tool chaining, that is our task 3. So in the task 3, basically what it is going to do is here we are going to basically as part of task 3 we would go ahead and reason itself based on the task that we provide. And in the task 3 I want to read test.txt from my workspace, count number of words in it and tell me the results. So let's try to do this. Okay, now if I have just commented the other runs, so I've done task 1 before, now I'll go ahead with task 2. Okay, so in the task 2 you can see the logs going ahead. So in this case, if you see for task 2, what we are going to do is the model sees that to read a file, count the words, give a result. It calls the read file, gets the content back basically, and once it gets the content back, what it does is it is going to count the words in its head, answers, and there are no intermediate write file needed. It handles the analysis itself. So, and in case if I want to run a bigger chain, we generally sees that the model never saw an explicit do step 1, step 2 instruction, and it figured out the order because the tool schema provided the dependencies obviously, and the design principle was clear schema and not procedural steps. There's one more function I've written is on the GitHub API. So in the GitHub API, I'm just showing the schema. What it is going to do is uh, first pattern is to get those respective endpoints that we have given as part of it to get the tokens. So you have to create a token in the GitHub token file. You can go ahead to GitHub settings, developer settings, and generate the token. And this GitHub endpoint function that you're seeing are going to use that token for you. It is going to authenticate based on the REST API that we have seen. So it has the same shape of endpoint, method, and body. The agent decides what to query based on the task over here. And token comes from the environment. The agent never sees it. It only sees the tool result. That's the line separation that you want to do. So agent knows what it asked for, not how authentication works. And if you can see the method dispatches over here, in these cases, get post patch, if the agent tries an unsupported method, it gets a structural block back, not a 500, not a crash, a readable message that it can act upon. And also on the error handling, if you see that in these cases, stated code is in the error, and if the GitHub returns 403, the agent reads that and then can decide to wait or try a different endpoint or report it to the user, because 403 is generally for the rate limit errors. And now let's go ahead and try to execute task 2 and see. So in this task 2, we are going to actual call the respective agent also and push it to GitHub. So in the previous file, we were only performing analysis and storing and writing the file and doing this operation. Okay, but in task 2, we are going to perform more information. Let me just run this, and yeah, so if you see now, so the model says I need to call the GitHub API for issues and picks the right endpoint, the issues, the Python and Anthropic SDK Python issues, and gets the JSON back. It reads the titles and bodies, draft the summaries. It calls the write files. If you go through the function over here, so this is the respective tool calling for the function, and based on the tool calling, we would be using the functions above. So if it is GitHub API, you call your GitHub API accordingly. So here, if you can see, I'll go through the respective responses ahead. So let's break it down. So what exactly it does it is going to call these two calls chain and no explicitly instructions on how to chain them. So what it does is it is going to call the web search. It returns the respective information for you. It is able to find out these three issues, and it has written it to the GitHub issues.txt, and all the final three output answers that it is able to derive. These are the three open issues that it is able to get it from the Anthropic SDK Python endpoint, and the summarization of these accordingly. So what it does, it returns the every tool with a result or error dictionary, and we have handled the exceptions also accordingly. So the agent loop itself basically passes these tools, and the models know what to call. So if you see the let me show up that message over here. So if you see this step, basically the agent loop itself, so it is identical to what we did in episode 2. So we are passing tool as tools, and the model knows what it can call, and nothing else has changed. And there's a stop condition also here. You can see in the stop condition, the loop ends when the model stops calling, and stopped reason is equal to means it's done reasoning and ready to answer. And then you have your tool dispatch to use. So in those cases, it will dispatch the respective tool to go ahead and um, back to the response.context. So when the type is tool use, as in this case, each block has block.id, and you can run the tool, get the output, and send it back with that exact tool use ID. The model matches result to call the ID. And we have the max step to check basically in these cases. So as we go ahead, in case if it has hit the max step, the agent would be stopped. So if it is also stuck in loop, calling tools without converging, this kills it at 10 steps, and it's not a crash but a controlled step. So now what exactly is the takeaway from this? So there are three principles for building agents with real tools. The first is tools are contracts. The schema is what the model reads. Make descriptions precise, type explicit, constraints in the schema, not in the system prompts. The second is the errors are data. So every tool returns either a result or an error dictionary. The agent reads error and adapts, never raise from a tool function. Third is guardrails at every boundary. So path traversal checks before touching the file system. Token from environment never gets from the agent. Max steps before the loop. Size limit before the write, lock it at the point of action, not as an afterthought. Next episode, we're looking for the memory. Right now, this agent forgets everything between runs. We will give it persistent memory task later. Here's the uncomfortable truth. Every tool call costs money, not the agent loop, that's fast and cheap, but search APIs cost, API calls cost, LLM tokens cost. A single agent task might call search 3 times, maybe $0.01 each, let's say $0.03, get 3 results, 1000 tokens each to parse, maybe around 0.003, get an API 2 times around $0.02, and generate 500 tokens of output should be around $0.005. So total approximately $0.06 per task. Scale that to 1000 tasks. So you are at $60. Scale it to 10,000, you are at $600. And that was a simple agent. A complex one doing 10 tool calls per task, it 10x that, which is why guardrails matters. Max step is equal to 6 means your agent can't call more than 6 tools per task, capping the cost even if it goes off the rails. Max tokens on the model output caps the LLM spend, and tool specific limits, for example, max search result is equal to true, caps the API cost. The agent without guardrails keeps looping, burning money. The one with guardrails stops at the cap and reports. So pick guardrails. Let's talk about how to design tools wrong so you recognize it. The first is for the vague schema. Call the do stuff function, takes any inputs, returns any outputs. The model has no idea when to use it. It will call it at a wrong time with the wrong parameters. Better, fetch data from database, takes a query string. Example, select star from users where country is equal to question mark, and a parameter returns row as JSON. So this is the first mistake that we do for the vague schema. The second is to overload tools. One tool that does everything: search, file input, output, API calls all in one function. The model gets confused about which tool to use when. The schema is a mess. Better separate tools: web search, read file, write file, call API, each clear. The third mistake is no error handling. A tool crashes if the API is down, if the file doesn't exist, if the parameter is wrong, the agent crashes with it, the task fails. So better is to catch exceptions, return structured errors, let the agent decide what to do. Fourth is no rate limit or validation. The agent can call the tool as many times as it wants. It searches 100 times, it writes 1000 lines, your cost spirals. So better is to have tool level limits. Max results is equal to 10, max file size is equal to 1 MB, max calls per task is 5. So this can be way to avoid that. The fifth mistake that people do is hardcode secrets. The API key is in the source code. If the code is ever shared, checked in, leaked, your key is compromised. So better use environment variables, secrets manager, never in your code. The sixth is no logging. The agent calls a tools, something goes wrong and you have no idea what happened. So better log every tool call, what was called, with what arguments, what was returned. So this makes debugging 100x easier. We talked about max steps in episode 2. Let's expand. So you see these max steps which is used so that the agent can't loop more than this many times. As part of max tokens, the model can't generate more than this many tokens per turn. So it will keep it focus and keeps LLM cost capped. And for tool specific limits, you can see the search max results, the file size max, the API timeout. These all could be the parameters. So these go in each tool schema, so the model knows them. Why do we need this? So basically, in case if max steps is equal to 10, it stops runaway loops. If the agent hasn't finished in 10 tries, something's wrong, stop and report it. In case if you have defined max tokens as 1024, it forces the model to be concise. Long outputs are expensive and often worse. So tool limits guides the model's planning. So max result is equal to 5, tells the model you can get the 5 results, so choose wisely. So that is what about the tool limiting. Okay, so you have now built agents from scratch in episode 2 and we have wired real tools in episode 3. You understand the loop, the tools, the guardrails. Question, do you need a framework now? Honest answer is probably yes, but now you'll use it right. Frameworks like LangGraph, Autogen, Anthropic's own stuff, they wrap the loop you build and add. For example, state persistence for multi-turn conversation and long-running agents, retries and fallbacks. If a tool fails, try again or use a different approach. Observability for logging, tracing, debugging. Structured output to make sure the agent's final answer is what you asked for. And multiple agents for coordination and message passing. But here's the thing, you don't need them for a simple agent. And if you use them before you understand what they are wrapping, you will treat them like a black box and get surprised. The pattern I've shown you, loop, tools, guardrails, is the foundation. Everything else is layers on top. So that's episode 3, real tools, search, file, APIs, error handling, cost awareness, guardrails, the stuff between neat idea and I'm shipping this in production. You now understand not just how an agent works, but how to make it work for real tasks without burning money or breaking things. And that's the difference between a tutorial and a tool. Next episode, episode 4, for multi-agent systems. One agent for planning, one for search, one for synthesis, how they talk to each other, how to make them work as a team. It gets more complex. But if you have followed along so far, you will get it. The book that I have linked in the description will go even much more deeper in all of this. So production patterns, cost optimization, error budgets, the governance stuffs, all those details are mentioned in the book. You can go through and buy it and let me know how do you find it. Link is in the description. So subscribe and I'll see you in episode 4.